Great, the crowd is warmed up. I don't think the union would like this wiring job here, so I'll try not to kill myself. Hello everyone. I'm very excited to be here. It's been a great NervesConf so far. This talk is Problems for Future Me, Practical Challenges in Maturing IoT Systems. Of course, warning may contain some slight profanity. Hopefully YouTube doesn't ding us for this. I don't know what they're like, if they care about that. I guess we'll find out. So just to kind of go over the structure here, I tried to split this into two parts. The first part is kind of general, maybe 5 to 10 minutes, so pay attention to that, and then hopefully the rest also. And if you're watching, that'll tell you a little bit more about what the rest of it is. And then the second part is more specific, more of a deep dive into some of these sections. So as far as the first part, there's an intro, then there's this like, too long didn't watch, this is all the kind of summary stuff. Then as far as the specific stuff, I'm going to talk about sort of a device life cycle. I'm going to talk about distributed migrations, and then a little bit of a secret, a reveal, the biggest problem, and then we'll do an outro and Q&A. And some of the takeaways I hope you get are, here are some, not challenges, but features you might not have solved or built yet. And the goal is not to like get all freaked out or like, oh, we got to put this on our roadmap. It's not premature optimization. It's like, where are our risks? And as far as time management, when do we have to start thinking about this thing? Hopefully, it's almost like right before you need it, right? That's the ideal case for development. And so some other questions to think about are like, does our architecture allow this? And, I come at this mostly from the combination of your firmware and your cloud software, like working together typically, although it might be either in the cloud or in the firmware. For some of these things, you might have manual processes. Are they good enough? If we have to do this for every device and we have millions of devices, well, that's going to be a problem. If it's only one device every once in a while, well, manual is fine. If there's any lead times, it's always good to recognize that. Of course, this is NervesConf. Where can Elixir and Nerves help? And lastly, I haven't seen nearly everything, and so I'm sure I'm going to leave a lot out here. So I think this is hopefully a good prompt for hey, what do we need to think about as our system lives and matures and ages like a fine circuit board? So hello, my name is Mike Waud. I'm going to cover just quick 2 projects I did recently because I think they're fun, and hopefully give you a little sense of projects I've seen that have gone from early to later. So this is a company I used to work at called KitCheck. And what we did is we put RFID labels on medications within hospitals. And you can see there's a picture of me lower down there with one of our early units. So these were like scanning stations, and you would put kits of medication into the scanning station, and it would tell you cool stuff like expiration of drugs, what was missing, what needed to be added, a lot of inventory kind of processes. There's another more finished, more polished picture in the bottom right. There's also an anesthesia project in the top right. I got to tell you, printers, my least favorite peripheral. Consider yourself blessed if you never have to do anything with printers. And so it was fun. When I joined, I think we had 4 hospitals, and when I left, we had a couple hundred. And they're certainly probably in the thousands now and millions of tags. So it was really fun to watch this go from small scale to larger scale. Within the Nerves community, you've probably heard of SparkMeter. SparkMeter makes and sells smart electrical meters. So these would talk over wireless to some sort of collector. In this case, the first revision was this industrial PC you see up top. That was actually designed to be offline completely, and then the cloud capability was added later. This was in Python, Postgres, Docker, kind of more traditional web type development stuff. And then you can see down below, this is actually a Nerves device. This is a single board computer with cellular, RF gateway, everything in there. I've given a talk on the Nerves meetup a little bit more about this. And so that Nerves was a huge help in getting this ready for the cloud. And there's actually been a bunch of work to now put Nerves back onto this industrial PC, much like we've heard from some other folks of bringing Nerves back to an x86 platform. And then just kind of a fun picture, you can see a lot of this was installed in emerging markets. So I think this is probably Kenya where they're installing this on a utility pole. And so, a couple hundred of these, let's say hypothetically out in the field, 6 figures of meters, not the largest deployment, but interesting to see the existing product, how that evolved, and then as the new product came in, where we got things right, what was tough, and all those lessons learned. And now I'm doing something called SQL Link. I won't go too much into this, but the gist here is, if you've seen any of my other talks, I just love this idea of moving data around and why is it so tough. Can I see who uses Kafka here? Like a little show of hands. Okay, maybe 2 hands or so. MQTT? Way more hands. That's like 50%, 40% of the crowd. SQS? Okay, also pretty big. Maybe a third, maybe 20%. And so they work great, but I think everybody kind of ends up building this custom syncing and delivery guarantee on top of it. And this can depend a little bit more on your usage case. Certainly at Spark Meter, I like to talk about how we definitely didn't want to lose a meter reading, but we absolutely could not lose if someone made a payment and we were supposed to then restore their service or give them longer service. We absolutely could not lose that payment that had to go to the meter. So reliable delivery and syncing was very important to us. And so we're engineers, we can build this certainly, but it really kind of ends up being a tax on feature development in teams. And we've seen all these AWS diagrams and services, and I'm just kind of sick of them. So with SQL Link, the goal is just make moving data around easier. We love SQL, we love all the concepts of Kafka, MQTT. We love junior developers. Like, how do we get people to solve this problem without having years of either Elixir development or knowing Kafka on top of everything else? And we want something that's predictable and understandable, developed locally, so you don't have to stand up like IoT rules and all these other things, or local stack, make distributed systems easier, and lots more. So come find me here if you want to talk about any of those things. I always love to talk about those. And so on to the actual talk now. Where am I going with this? I think there's this interesting thing called the product development lifecycle. And you can kind of see there's development to introduction to growth to maturity. You can find a lot of infographics on this. But we could try and be real engineers about this and get real academic and say, oh, well, at the beginning we have this development cycle and that's where a lot of our costs are. And particularly with hardware, that's very true. And then as the product ages, well, that's where we're actually making our money, right? But at the same time, we have the cost of change grow up. But I like to simplify things, and I think we could just say, give me an X and Y axis, X is time, and Y is the shit you have to deal with, right? And guess which way the arrow goes? Up and to the right. And this is the way I kind of think about this. And it's funny because at the same time, maybe you're experiencing this as your product goes on and on, your CEO or your manager or someone is telling you, well, actually, it's the other way around, things are always getting better. And you're looking at this and you're saying, well, I don't know, it kind of feels like everything's the same. And I don't really have any solutions to that, but, I think we can all hope that over time, we are able to reduce the amount of shit we have to deal with through being smart engineers. So for those of you who have worked on systems a long time, I'd just be curious, just shout out, what are some of the challenges you've seen as you've had something that's gone through weeks or months of a lifetime and has grown some, has grown some years, I'm just gonna pick on someone. Where's Alex? Alex. Okay, ignoring problems I'm hearing is a problem people have.
Well, if you want to talk like cellular, for example, that's a good one. So
okay.
Deal with flaky connection over time.
Oh, yep.
Scale that out. Now you've got more and more.
Yeah, that's a good one. Maybe your first couple deployments, cellular works, and then all of a sudden you're getting some weird like TTY bug or something, only at one site or every once in a while. Yeah.
Well, maturing. This is more a question for you. Are we talking about just systems getting older or declining? Like that, we're just talking older but not increasing in quantity?
I think both is very much fair game. Yep. Dealer's choice on that.
In terms of quantity, there's provisioning, there's installing,
Yeah.
there's a whole process around
Yeah.
manufacturing an IoT system or manufacturing goods. It's on the customer site working.
Yep. So the answer was kind of manufacturing and just maturity and getting it on the customer's site and working. Yeah, that's a good one. Ben.
IT is going to wake up one day and they'll realize that you have 100,000 devices pushing data to the server, and the server connection went down for a minute.
Yep.
Now it's back up, and everyone needs to talk to it.
Okay. Would you say like Thundering Herd is kind of your gist there? Yep. That's a great one. Yep. You know, you were growing these devices and you didn't have an outage or something, but you did, and maybe you have a perpetual outage because of this Thundering Herd.
Check the Solinger.
Yes, check the Solinger, yeah. If only we had a time machine, Smart Rent team, I'm sorry. John.
Complexity.
Complexity, yes.
Goes through, you understand the problem more, complexity increases.
Yep,
Cooks in the kitchen.
yep,
Stuff in.
yep. That's a good one. Okay, yep. Well, I'm the last talk, so no one's after me. Sure, hit me.
You get a client who is really into you,
Mhm.
and they like your product, and all of a sudden, you wake up one day and they're 60% of your income, and now they want something else.
Did you say Grafana, or what they like what?
They like you, they like your product, they like your features,
Yep.
it's good. And you wake up one day, and now they want new features. And they're
Okay.
60% of your income.
Yep, so this is the like classic big customer case who wants a new feature, and you're just, you know, you got to build it for them.
Knowledge loss, resource loss over time, people leaving.
Yeah, knowledge loss, research loss over time, really good one there. And so it's basically a lot of stuff what people said. Over time, you're going to have more data. You're going to have more devices. You're going to have more 1 in a million events. You know, this is kind of like the cellular thing that Alex mentioned. You're going to have more team members. You're going to have more software features, more hardware revisions, hopefully, more weird customer requests. You know, if they have money, they're more likely to be built out. And you're also going to have less stuff, right? You're going to have less team members. You're going to have less data. Maybe you had an outage, or God forbid, you lost some data, and you have to figure out how to make the system whole. You're potentially going to have less budget, especially based on that graph. You know, the company wants to make money on this, and to make money, they're probably going to spend less money. Some things are also going to be the same. You're going to have potentially the same installed hardware. Like, just think about this. The hardware you ship now is potentially going to be there for like years. And you're like, well, I can turn it off and turn it on again, but I can't change the wiring. So that's something you're kind of stuck with, right? And you're also going to have churn. So you might have more of something, but that you can have less, and just dealing with things that have changed over time. And all these kind of cause downstream effects, right, to the ultimate problems that we have. So more on Elixir and Nerves and where they can help. You know, I think it's been covered probably to death. The shared language has a lot of benefits. Being able to test with like mixed target equals host and in CI, and just like the testing story around Elixir and Nerves is like phenomenal. Integration tests especially, being able to bring stuff up in the cloud and on the firmware, super, super helpful. The actor model and OTP are just such a great way to think about concurrency and resiliency. I think that's been essentially like proven out. And the ecosystem, you know, being open source, and just the amount of work that goes into this just keeps getting better and better. Nerves Hub, certainly covered, but to have like an over-the-air firmware update system, like basically out of the box, is incredible. And to have the console access and like, I don't know, like this console observability and debugging on Elixir is just so amazing that you can get a console to the device. And it's not, in some other languages, it's like you're bringing up like a parallel instance, but this is like actually the beam. And you can get all this fantastic information from the beam, whether you're attaching to an existing node or cluster, or whether you're running something magic like recon trace, where you're actually saying like, okay, the next 5 times you call this method, tell me like what the inputs and outputs were. Like, I'm sure you can do that in other systems, but it's just like to see it in production is magic. And I've actually been on a call with a well-known vendor, and we were like debugging some issue, and they said, oh, well, you know, you could try this, kind of expecting like in a week we would get back to them, which of course is like scheduling calls and jumping through hoops to get their highly paid engineers back on. And we just said, okay, we'll just open up a console in Nerves Hub and we'll like run this command. And they weren't like, that's amazing, but we did get a wow from them. And I thought that was pretty cool. So Elixir Nerves totally gets you a lot. So that was the like part 2 general stuff. Now we're moving into the specific. And so device lifecycle, here's our friend, the Super Nintendo. And even the Super Nintendo gets a little haggard after a few years. And this is what happens to our devices. So I'll cover a few things here. We'll get to them in time. So we'll start with lifecycle progression. And so, your device starts as a bucket of parts, right? And then somewhere in manufacturing, it's assembled. And then it goes through presumably some sort of end-of-line testing to make sure that, okay, this cellular modem works, or like this thing just boots, right? Hopefully you're doing this before you box this up and ship it. Maybe there's a burn-in step, probably not, but I've seen that. And then eventually, it passes end-of-line testing, and there's probably some provisioning, the firmware's loaded, and then it goes into like your inventory, right? And you're manufacturing these in runs of X numbers. And then it's shipped off to a customer or something, and it goes through some installation and commissioning process, and then everything looks good, and it's commissioned, and then it lives this long, healthy life, and eventually it's put out to pasture and it's decommissioned, and you're kind of done, right? And this is the ideal life cycle, of course, because in reality, it's a little messier. You have stuff that was commissioned, and now all of a sudden you don't know where it is. You have stuff that like skipped end-of-line testing and is at a customer site, or maybe you had some hardware that like wasn't that bad, but it went back to manufacturing to be recommissioned, and now you're not sure where it is. And some of this will reflect just the maturity of your like manufacturing and like ops org, but it's still like weird stuff is going to happen. And so the real world scoffs at your process diagrams, right? And so I think Erlang and the Beam give us this great idea of let it crash, And my recommendation here would be don't try and cover every case, but at the very least, be able to kind of fail your stuff back to inventory or back to assembly, and then let it go through kind of the happy path up. And hopefully you don't have to do too much like data wrangling to get stuff that was in commissioned back into inventory. One of the challenges really here though is like if the device is offline, that can be a real pain, whether it's engineering or some support org that needs this device to be online before they can fix this stuff. So ideally you can do this offline. Definitely have some thoughts on that, but I'll leave it out of this talk. So that's a big one for device lifecycle. Inventory, talked about this a little bit, but I think about this in terms of two things. One is interfacing with manufacturing, and another is updating old firmware. And so the manufacturing thing is pretty interesting. I think probably everyone will have a slightly different flavor of this, but these end-of-line tests have to come from somewhere, right? Is it the hardware group that comes up with these? Is it like the Elixir team? They might be the same. Like, where are these tests coming from? They're probably in Elixir. And probably few of the like lower level hardware people know Elixir. So you're gonna have to like say, here's some like test protocol for the cellular modem, or like just to make sure that the eMMC works. And those tests might need to be updated and maintained. And kind of manufacturing process is almost like this automatic second product that you get that you have to maintain whenever you have like connected devices that you run. You're also going to have some initial firmware image which you have to load onto the device, right? When it boots, it's got to do something. Like how does the knowledge get in there? So you have to think about that. What are you going to put on there? How are you going to update it? Maybe you have some provisioning process. If you're putting like certs on there or something, or you're telling it which, like which server to connect to. There's some sort of interaction with manufacturing, really to get these authentication credentials and sort of this like device identity. And maybe you're a mature organization and you already have something for this, or your manufacturer's really good and they tell you some process that works. Either way, you're going to have to come up with something that works. And you're probably going to miss some stuff, and you'll have to figure it out. So updating from old firmware, do we recognize this movie scene? So this, of course, is the Ark in Indiana Jones being like tucked away forever. And this is what happens, right? Your devices are manufactured in big batches, and then they sit on the shelf. And so by the time it's plugged in, your firmware is weeks, months, potentially years old. And you have to make sure that you can update it, hopefully not with manual intervention, hopefully there's still like some update server and like some certs didn't expire, and it's not like, oh crap, how do we update this thing? It's something that you have to think about ideally from the beginning, and then also just make sure that it keeps working. So demo units, had to deal with this a lot. I always think about this as like there's a conference and someone's like, oh my God, we forgot to tell you we have a conference in a week, and we want to do this really cool demo for this feature, and we need our data exactly this way, and we need to be able to reset it all these times. Am I off base? Like, have people experienced this? This was definitely a thing I've run into. But so having like sales and conference setups for this is something that can really suck up your engineering time. But it's something to think about, because you also at the same time have developers who want to set up specific situations to test features or problems. Or you have QA who they want to test some feature, and they can click through all the stuff, but sometimes they're like, I just want the data to do it. So you have to think about how to actually get your system to behave or like jump through the hoops back in that process diagram to potentially like replicate a bug. And how do you do that, again, without sucking up all this like engineering time to support this? And so, yeah, if you have like offline devices, or like you have to like blow out your hardware database or something to do this, it takes some really interesting coordination between triggering this in the cloud and then actually running it on the device and confirming that both have happened. I don't have any great answers here, but it's a problem to think about. Hardware swaps, this is kind of the case where you have to replace hardware. And can I see who has had to replace hardware that has failed? Just a quick show of hands. Okay, I see some hands. Who has had to replace hardware because of a volcano? So this is the city of Goma in Congo. And there was a volcano there in 2021. And it was a legit like national disaster, but fortunately the city was spared. And I think, it's a good reminder, A, of just like the real people at the end of these devices. It's important to make them work and to have like a replacement process for them. But then also, like weird stuff happens. I didn't think I was going to be dealing with like volcanoes when I started at SparkMeter, but it happened. So just a few quick notes on this. When you're replacing failed hardware, be careful if your device history is like too tied to like a serial number or something, because that could potentially go away, right, when this device goes away. Ideally, you want some sort of like abstract ID to associate, the apartment 2B floor 5 or something, such that when you replace it, all that stuff is still there in some fashion. You also have to configure this new device. Like how do you get the configuration that was on the old one onto this? If you had something that was like 5 or 6 messages, can you send them all in the same order? Do you have like some new configuration thing? Is it just a file you put on there? This is the case where maybe your manual processes are fine, but man, if you do it as a manual process, write it down, because the next time you do it, you're probably not going to remember otherwise. So that's a big recommendation there. And then lastly, sometimes you think the stuff is dead, but like the customer still has the box and they like plug it in. And you're like, oh crap, why do I see 2 of these sites? So make sure you block that old device from communicating, or if they're going to reuse it, make sure you have a way to kind of like explain that this thing used to be over here, but now it's over here, and it doesn't look completely weird. So distributed migrations, I think of this sort of like database migrations, but harder. And so keeping with our theme of thermostats, we have another thermostat example. So imagine we have like some internet connected thermostat, right? And our 60% customer comes to us and they want a feature, and they say, we want to be able to set an alarm temperature in the cloud that goes to the device. And when that device crosses this threshold, it like sends some alarm somewhere. Maybe it does some like process, it actuates something, and then it also tells the cloud that like, hey, this alarm was triggered for whatever our downstream data collection processes are, right? So, okay, we just make 2 messages. There's like a max temp, and then there's like a temp it was triggered. You can add like, imagine the fields you could think of, right? And so we send the config for this alarm, and when it's triggered, we send the temp. But to get this actually out, there's some really interesting deployment sequencing, right? If we were doing traditional web stuff, we would just like push this out in one go and we're good. But instead, we have to like make sure that we can receive this alarm trigger first, right? And then we have to deploy the firmware such that it can receive this configuration and then also send the alarm trigger. And then we also have to make sure that the cloud can send the alarm config in the first place, right? And we have to make sure these happen in like a certain order of operations. You can also do something like a feature flag. So you could have basically everything in the cloud, and so it can receive, but like the feature is not like enabled, whether in the UI or something. You do the firmware, and then you flip the feature flag. But once again, our old Nemesis offline devices shows up, and we say, well, if a device has been offline for like 2 days, do we still do this? Like, do we wait for like X days or like X number of devices? How do we make sure that like we're not sending things to firmware that the device can't process? Another thing you could do is check the firmware version when creating like one of these configs. You could say like, oh, that device is old firmware, so like wait. But customers don't like that, right? They want to like change things now. And so my recommendation here is to have an ability to like require a minimum application version, such that if you have a device connecting, which it can't like understand the message you're going to send it, tell it to like update before it can connect. It's a personal preference, but that's one way to solve this issue. So we're going to keep going to this thermostat example. And now let's say our 60% customer who we want to keep happy, they now want us to, they like the alarm so much, but because of their business, and it's only 9 to 5, they want to set like a time of day and like different thresholds of like during business hours, it's whatever, 65. After business hours, it's 68. And they want to do one or the other because some they just care about that flat max temperature. Others they care about this. So we have to support both use cases. Now all of a sudden we have to figure out how to support all these devices in the field while rolling out this new feature, right? So one option, of course, is just like hack on a new field. And we just use JSON or protobuf or something, and there's just a new field, and we have a big gnarly if statement or switch statement or something. And we just choose which implementation to use. I think you can see the problems with that. Another is to add an additional message, right? The first message is this any time of day, just regular temperature. And then we have this new message, which is this time of day with a different temperature. And we just choose which message to send based on what they did in the UI. A third way is to like change the structure of the original. You know, maybe this is like V2 of that, and have like a polymorphic message. You know, very similar to like database migrations, right? You're sort of changing to a polymorphic relationship. And then we do this out. We eventually deprecate the old message. This is probably the most common thing I've seen. Probably what I'd recommend. And then option 4, which is kind of weird, but also possible, is you can send both messages, right? If you're moving to this V2, you could send V1 and V2 at the same time. And one of the benefits here that you get is you can roll this out in stages, right? You could try it to like an initial device, just to like make sure this doesn't crash. And then you could say it looks good before you completely go whole hog on this new structure and feature. And so once again, we have deployment sequencing questions with this. You know, how are we going to roll this out? You could probably do it the same thing as before with like a feature flag. You can also, there are certain situations where you could move to just this like V2 structure. And you can have all the structure there before you actually implement the feature. Pros and cons to doing it either way. The nice thing about the last part is if you already have firmware going out, you can just like kind of tag this along. And then your structure is like already migrated. You just have to implement the feature. Piece of cake. But this is like one of the big challenges of once you have these devices running and you want to change something, it's like, how do I change this without making things crash? And so those are two big ones. We're going to move on to the biggest problem with maturing systems. There's this really interesting Microsoft study of predictors of failure proneness. And this was actually a study of Vista. So you know they had some good data. And so we see these things that we hear about a lot: code churn, code complexity. number of dependencies, code coverage, pre-release bugs, and I actually have a prize for this. On the way down here, I stopped at supposedly the nation's best bacon. And the first person to answer this gets some Benton's smoky country ham, country bacon, or can gift it to whoever they would like. So what do people who are interested in winning potentially free bacon think that this question mark could be? Lines of code. Okay. Human error. Developer churn. Ooh, how do I categorize this? It's really between human error and developer churn, I would say. Organizational structure is what they termed it as. And so what's really interesting is they then quantify this in a couple different ways by like number of engineers, number of ex-engineers. So like engineers, number that have worked on the product, number of ex-engineers, people who never aren't there anymore, how much it's been edited. I guess that's kind of like churn. And then they go into whole other different things. But you know, I think this goes on to like the institutional knowledge point you mentioned earlier. So, oh man, this is tough. But I got to give it to the Nerves core team member. Come on up here and get your bacon, John. There you go. Congratulations. And so again, if we think about our product lifecycle in just like a slightly different way, right? We go from this initial concept, and this thing's then greenlit, and you're like ramping up your team, and you go to like an alpha and a beta and a 1.0, and scaling into features till eventually this thing is like retired, it's out to pasture, right? And reality, in the human part, you have Alice, who's there from concept to 1.0, and then Bob, who's there from alpha to scaling into new features, and Carlos, who only shows up, you know, after this thing is already launched. And there's so much of this institutional knowledge, things that worked, it didn't work, why things are the certain way they are, which bugs are actually bugs and which aren't. And so this is definitely something I think about a lot, because it's also just like a fact of life. You know, people change jobs, they move on for whatever reason. But I do have some thoughts about what we can do about this. And so, you know, certainly just general practice, right? We want to lower the cost of failure. How do we fail sooner? But like practically, how do we do that? Okay, that sounds good. Well, certainly unit and integration tests help this, right? They're sort of like designed to fail almost. And being able to run this locally helps you fail faster and sooner and safer versus like learning this on production, right? Like how can we do more of these things to make sure we're not breaking things before they get out and people see them? Document manual processes and share tasks, you know, boring, but having like a run book that tells you how to go through a certain manual process and checklists are super helpful. Even if you're like a one-person team, like you're gonna forget this the next time you do it. And this is a big one. It's definitely a muscle you have to exercise. Leave a history, again, boring, but sorry, really helpful. Taking notes, you know, one of my favorite things if you use like the Google Suite, in a meeting, there's like a take notes button, and it'll associate the document with the meeting. And I love taking notes in that, just to come back to things like what decisions do we make, you know, what were good things to remember. And in this weird world we're going to do with like AI everywhere and searchable everything, I think this is only like more important to like write down this stuff. And eventually, you know, chat whatever is going to tell us like, oh, this feature's there because 6 months ago someone said this thing in a meeting. So there's that. Write comments, you know, if you're using Jira or something. It's probably fine to keep it in Slack, but Jira comments can be a good way. Anything that's searchable, basically. And, you know, lastly on this one point, like fix documentation. If you see documentation that's out of date, be the hero, be the change you want to see, and fix it. Avoid the drunkard search. So there's this story of like, it's late at night and this policeman's walking around and he sees a drunk guy under a streetlight. And the drunk guy says he's looking for his keys. And so the policeman says, okay, you know, I'll help you, drunk guy. Hopefully he's not driving his car. I don't know, the story's a couple years old. And so after a while, the policeman says, you know, the keys aren't here. And the drunk guy says, oh yeah, I dropped them like half a mile back. but I'm looking under the streetlight because that's where the light is. And so I think the takeaway here is like, don't look in the places it's easy. Like if you're within your own team and the person who used to know about this thing left, you're gonna need to talk to the product manager, or like you might need to go into that code base. You're gonna need to do a lot of spelunking outside of just like the GitHub repo you're used to looking into. Or if you're like the new person at a company, you gotta go outside kind of like your comfort zone. And I know you guys all know this, but always good to hear it. Always good a reminder. Retain your best people, not always possible. Institutional knowledge, though, that's a big one. And I don't think I put it on here, but like sometimes people mistake lines of communication for like lines of authority. And just make sure that people feel like they're free to talk to each other in the org, and that lines of communication are not controlled. Build versus buy, you know, we're engineers, we like to build things. But be wary of that, because when you build things, you are essentially buying from yourself with a much smaller vendor team. And if the person who built it leaves, you're now kind of stuck with that bespoke thing. I say this having also made bespoke things. But you know, I think this is one of those places where like open source is just such a great way where you share the thing and then hopefully it takes on a life of its own. So when you can find something, buy it if the price is right. Another big one on this whole institutional knowledge thing, I think, is like finding home for orphan systems and retiring them. A situation I've seen a couple times before is like, again, some engineer comes in and makes a system or like is the expert in something. I'll just pick on something and say like Elasticsearch, and like 99% of the time this thing runs fine, but then it has like an issue, and everyone freaks out because like Elasticsearch is down, or like someone else can see it's about to go down, and someone does the right thing and they're like the hero, and they go in and they read these Elasticsearch documents and they like fix it and it's back, and everyone's like, yay, I don't have to deal with Elasticsearch. And this kind of goes on until it breaks again, and then everyone's like, oh hey Joe, you fixed this last time, you're our Elasticsearch expert. And Joe's like, oh God, what did I do? And you get into this anti-pattern where people learn that if they fix things, they now have like one more thing to do. And so I'd say, you know, lean on your managers for like whatever the correct solution is, but I would say make sure you're not falling into this anti-pattern where people are afraid to fix things because it's gonna mean more work for them. I'd say like just assign that thing to some team and be like, okay, it sucks that we're giving you this, but here's some time to like make this better, and hopefully deal with it that way. Lastly, you know, there can come a time where you need to re-platform, whether you're software or hardware or completely both. This is a whole nother topic. Probably a lot of my career has been like re-platforming, so I have strong thoughts on this. But yeah, it can super work. So just kind of a quick recap. You know, we talked about all these general things. We talked about specific stuff about lifecycle and these distributed migrations and the human factor. And so, you know, this is our haha, we have to deal with a lot of crap. But really, like if you have a product that's still going, like that's pretty impressive, right? Most software products fail, like most hardware fails. Just the fact that you're surviving is impressive. So I think keep that in mind whenever like you have a late evening or like this thing isn't working. It's like, it's tough because it's still working and people want it. And hopefully that means like you've shipped more features. And you know, maybe worse, like exponential, and like users impacted has gone up. Like if someone's paying you to build this, that hopefully means that like you're making life better somewhere for everyone. So in summary, you know, software is hard, hardware is harder, and you're the guys who picked both. So it's really all your fault. Thanks so much. All right, questions? I think that's everything. Yep.
Right. Thanks, Mike. So you mentioned some strategies for evolving a protocol in there. One of the options that I didn't see on the list, and this totally isn't from repressed memories, is what if deprecating the stuff that's already in the protocol isn't an option? How would you manage that?
You mean something like protobuf where like you can't remove an old field kind
Yeah.
of thing? Yeah. So I guess what I meant there is if you have a protobuf like message type, like that message type is now not used anymore. Like that RPC is just like, whatever V2. Not so much adding a field, yeah.
So like leave the property, but just don't deal with it. Kind of like sunset it out, but it just kind of lives on in the protocol itself.
Like it's a completely new message, I think. Yeah.
So the constraint would be this is a tough
Right.
one. This is why I throw this at you.
Yeah.
So you're stuck with the same message type, and you can only add properties. You can't remove.
Okay.
You can't remove any.
Yeah.
Yeah.
I mean, that's an organizational decision. I think it's a when do you make that call, right? To keep adding versus like clean slate kind of thing. I'd say I would punt and say it's an org thing. If you're going to keep adding, I feel like you can always like. It's like in The Simpsons when they like take Springfield and move it to like New Springfield. That's how I feel like with these like columns. I feel like you can always like add a new message type. It's like adding a new database table or something, right? At some point you just say like this thing is ridiculous. We're gonna add a new one, and hopefully that is less pain than like maintaining the old gnarly one. Yeah.